Hello there and welcome to this workshop or this course. My name is Valentine and I'll be your instructor. In this workshop or in this course, we're going to be taking the following structure. We'll get started learning about the objectives of the session. After that, we'll get into a 10-minute section where we will talk about what data engineering with Python as well as Cassandra, or if you would want to call it more specific, Apache Cassandra, will entail. And we'll just talk about why we would want to perform the different techniques, especially when it comes to data engineering. And those reasons would be reasons why organizations might want to use both technologies. Then after that, we'll get into a practice session where we'll get to practice how to create data pipelines, which are systems that collect data from various data sources and transform the data as well as load the data. So we'll get into an hour practice session, and after that we'll talk about the next steps. So let's get started. By the end of today, we expected to have achieved these learning objectives. We should be able to describe the core concepts of building data pipelines with Cassandra. We should also be able to describe scalable or build scalable and efficient data pipelines using Python and Cassandra, and be able to integrate Cassandra data pipelines with other tools and systems. So what is Cassandra, or Apache Cassandra, and in the context of data engineering with Python? Generally, data engineering with Python, just taking a bit of some step backwards, data engineering with Python and Cassandra involves designing and building scalable data pipelines. These, again, as mentioned, are systems or solutions that we create using various tools that allow us to collect data and transform it. So this process of using Python and Cassandra would allow you to create pipelines that are scalable, solutions that can handle large amounts of data. Apache Cassandra is generally a free and open source database system. You might have heard of, in many contexts, SQL. SQL is a language that we use when it comes to interacting with what are called relational database management systems. If you've heard of MySQL, Postgres, SQL Server, those are relational database management systems. And they are one type of databases that we can be able to interact with. There are other types of databases aside from those relational database management systems. There are what are called NoSQL databases, and Cassandra, Apache Cassandra, is one of those NoSQL databases. You might have also heard of MongoDB. It's a NoSQL database, which means generally that it allows us to store structured and unstructured data. On the other side of relational databases, you tend to store structured data, data in tabular format, data that has some sort of structure. It could be integers. It could be that you have text data, you have time data that you'd store majorly in relational databases. But when you have data that sometimes changes, it comes in different formats, then you can use NoSQL databases, database management systems such as Cassandra. So Apache Cassandra, which is the name, it's a full name. It was, by the way, developed by Facebook, but later onwards given to the Apache Foundation and maintained. It became to that organization would continue maintaining that database. So Apache Cassandra itself would normally store data in what is normally referred to as key value pairs. But still you would tend to work with tables at a particular point. Just to give you also some better idea of how you would store data, in Apache Cassandra, you would create a database. Then inside a database, you would have what is called a key space. You can have multiple key spaces within a database. Then inside the key spaces, you can have now tables which have rows of data. And you can have your data stored in those tables, but now in either structured data or unstructured data. It can vary because with Apache Cassandra, you have that flexibility of storing any of the type. Something else to note is that how Apache Cassandra works is that it allows you to be able to store lots of data, and it also allows you to be able to store them in a secured way. So you can use what is referred to as, well, not really referred to, but data would be stored in what are called clusters, which would be more like multiple different machines, which would tend to store copies of data. So if you have maybe some data that you want to store in Apache Cassandra, that data would be distributed across those clusters. And a cluster can be you can think of it as I don't want to use nodes. So technically, when you drill down, when it comes to defining a cluster is usually a collection of nodes. So data would be stored in multiple nodes. Could be nodes would be just where data would reside, but now you would have, assuming you have a full environment of where you have multiple clusters, some data can be stored in one particular, the data that you have can be stored in one node that's in one cluster, and the same data can be stored in another node that's in a different cluster, which allows you to have this secure approach when it comes to storing data, just in case, maybe one machine is down, you can still be able to retrieve the data that you would need. So generally, Apache Cassandra allows us to store data in a secure way, but at the same time store either structured or unstructured data, and it's well suitable for large amounts of data. The different components that make up the Apache Cassandra database. So there are what are called nodes, which would in computer terms be described as a single server instance that is part of a cluster. A cluster can be a collection. It's actually a collection of nodes, but now you can think of a node being a single server. So a cluster can have multiple single server instances. A cluster, again, group of nodes that work together to store and process data. And you can have a cluster that has just one particular node or hundreds of nodes. There's a data model which generally would define how you store data in a node. You can store data in key value pairs as well as in tabular data structure, so structured and unstructured data. Now, when it comes to interacting with data inside Cassandra, you can query or you can retrieve the data using a language called CQL. It's just like the way you have SQL on the relational databases, but when it comes to working with Cassandra, you have what is called CQL, which is Cassandra Query Language. It's much similar to SQL. So the way you would select data, let's say select all records from a particular table, then you use select star from table name. The same case, you can still use the same command to run on this other side, but now that query would be what is called a CQL query. Replication is this a concept that Cassandra uses to store multiple copies of data across just different nodes to ensure just high availability and fault tolerance. What we've talked about, if maybe a cluster is down, then you can still be able to retrieve the data that you might have stored. Petitioner is just a component in Cassandra that allows you to be able to distribute data across different nodes within a cluster. So it determines which node is responsible for storing just each piece of data. So those are just some key core components of Apache Cassandra. I hope you are now getting some understanding of Apache Cassandra. Moving on in terms of benefits, so just to summarize, there's the idea of scalability, because you are able to have multiple clusters and which can grow. Then you are able to store large amounts of data. So it's by default designed to scale. So you can have lots of data stored in Apache Cassandra. You also have this idea of fault tolerance. So data is replicated across different nodes, which allows you to be able to still work with the data in case of node failures or network petitions, etc. Performance, Cassandra is also optimized for high write throughput. So if you have lots of data, then you can be able to still be able to access the data with ease using Cassandra. And again, flexibility, you can store either structured or unstructured data. In terms of trade-offs, complexity, so this is not like any other database. This just increases when you use Cassandra. You tend to have some sort of complexity because now you're working with structured and unstructured data, which can be a bit more complex to configure, especially for replication. You might want to also determine which nodes actually how many nodes you want in a cluster, all of that. Sometimes it can be a bit tedious, especially when you're working with lots of data, as opposed to traditional databases where you just create a database and you can just set a few configuration settings and you're good to go in a production environment. Resource intensive, again, that distributed nature, that idea of having multiple clusters essentially means that you again have to set up multiple hardware computers or equipment. So because if you want multiple clusters and you have lots of data, you need multiple CPUs, and then again that means it translates to money, more cash for that. And query flexibility, as so the when it comes to querying, yes, you can be able to work with Apache Cassandra for just basic tasks, but when it comes to complex queries, complex joins, then it becomes a tedious task, especially for analytics. But in most cases, what you just want to do is to pull just the data that you need. Instead of doing just data analysis work within Cassandra, you just pull the data that you want with just basic queries, and then transfer that data into a different environment, maybe like Python or R, then do your analysis there. So those are just a few trade-offs. So generally, so the last thing I'm going to talk about is just a summary of what we've talked about. So when would you want to use Cassandra for creation of data pipelines? Again, when you have large scale, high traffic applications. So if you have lots of data that you're collecting, and you need to ensure that that data is securely stored somewhere in case of maybe node failure, you can still be able to retrieve that data, then Cassandra would work. Again, if you have just basic use cases for your data, maybe for the use cases, you may not necessarily need to work with Cassandra. You can just use the normal relation or even just a simple NoSQL database like MongoDB. If you have time series data, maybe sensor readings, logs, telemetry data, and you have lots of it, and you would need to have that data stored securely, maybe for auditing purposes or for maybe some sort of analysis, that's high-stake analysis, then you can use still Cassandra. Yeah, so a few examples I've indicated there, just maybe for maybe further elaboration. So if you're working maybe with IoT devices, e-commerce platforms where you have transactional data, then you can always look towards that. But yeah, so that's generally Apache Cassandra. It's just like any other type of database, only that it has special features. Yes, by just like any other database, I mean, you can store data, but now you store data differently and you query for data differently, or somewhat differently from what you would in with some other tools. So yeah, so at this particular point, we've finished that part of just talking about why you'd want to use Apache, what Apache Cassandra with Python, and why, and you probably now are ready to go to our practice work. So at this particular point, visit the description section of this stream, click on the practice resource link that should take you to a page that looks like what you're seeing on your screen. So you should get to this particular page and click on the sample practice resource. which should take you to this page. This will be now where we are going to be doing our practice work. Feel free to pause the video, and if I'm too fast, again, you can always rewind a bit so that we are on the same page. So yeah, do that. Click on the practice resource link, then should take you to that first page that I've shown you. Then click on the sample notebook, which should take you to this page. If you're an afterwork member, which we highly encourage, if you're really serious about learning how to become a data analyst or data scientist or data engineer, you have access to the practice notebook, which is just a copy of the sample notebook. Only the practice notebook has more challenges. And we also have a solution notebook that allows you to verify the challenges, the solutions to the challenges that will be there. All right, so starting off, I'll be using the practice notebook, by the way, for just ease of learning. It's not so much different, again, from the sample notebook. So once you get to the sample notebook, go to File, then save a copy in Drive to save a copy of this notebook so that you're able to make changes in the future in case you need to, or even just you're able to review your work that you have done today in case you need to review. So go to File, save a copy in Drive. It will open a new tab, a new copy on a new tab. Close the old one and open the new one. I'm not creating a new copy, by the way. I don't want to have many files in Google Drive. So it will save a copy on Google Drive. Once you've done that, the next thing that we need to do is to go to prerequisites. Just so go to prerequisites, and then we are going to install the Cassandra Python driver. So initially, when you're working with Python, Python is just a programming language that we normally use for various use cases. You can use it for data science work, for engineering, data engineering, or even for software development. If you want to work with Python and Cassandra, you need to install a library that allows you to integrate the two. So if you want to connect to a database somewhere, whether it's Cassandra or MongoDB or MySQL or Postgres, you need to install a respective driver or a respective library. In our case, you're calling them drivers because they're connecting to a data source. So let's install just by clicking on pip install Cassandra, Apache Cassandra. So click on that, it should install. You might get a prompt or pop-up, just say run anyway if you do. So let's do that. It should take a few seconds. Yes, mine has. And then once we have installed the Cassandra driver, we then would need to import a few necessary libraries. Actually, import Cassandra, but we also import JSON to be able to work with some JSON data that we're going to see. But just run also this cell, which should import a cluster class as well as plain text auth provider to help us be able to configure our security details or some configuration details or connection details to our database. So once you have done that, we have installed Apache Cassandra driver for Python in this notebook environment. We've also imported the libraries that we need. Right now, what we're going to do is we are going to create an Apache Cassandra database. We will create it somewhere in a different place online. And then we are going to connect to that particular database and be able to store data, update data, delete data. So we'll perform those operations, which will be essential for us to create data pipelines. Because when we get to creating a data pipeline, you realize that we need to, as part of creating a data pipeline, extract data from, let's say, as Apache Cassandra. So to extract or to retrieve or query data from Apache Cassandra, we will need to understand how to use this driver, which we will learn how to use it in this particular section for reading data from Cassandra. So we'll learn how to, pull data from Apache Cassandra, assuming that maybe the organization that you're working in or you end up working with has an Apache Cassandra instance. In many cases, the idea is just to pull data into a data pipeline. Then once you have extracted that data, you could merge it or then with other maybe data from other data sources, perform some data transformation, then later onwards load it somewhere. So we'll get to learn first. But right now we're just going to learn the basics of how to, first of all, set up a Cassandra database with one of just the many popular providers. These are providers that you can use even in production for many organizations. But again, you can also do this locally. The only thing that you're doing here is just making the work easier so that you don't have to focus on installing locally. Maybe you might get errors. And in this workshop, we're just aiming to just do this workshop in a record time of just 2 hours at most on your side. Again, if you feel like you're lost, feel free to pause the video and rewind, or pause the video a bit, do a more clarification online, just Google a few things, etc. All right. So once we've imported Cassandra, the next thing that we need to do is to create now a Cassandra database. There are many places where we can create a database, a Cassandra database on. So we can decide to use AWS. We can use Google Cloud. We can also use Microsoft Azure. We can use DigitalOcean. You can use a whole lot of other different data sources. Or you could even decide to have maybe your own web hosting service, and you can still install Apache Cassandra inside that machine. And the steps are normally not different from what you would do for relational databases. But now we are going to be using, to make it a whole lot easier to manage and be able to work with Apache Cassandra, we are going to use DataStax, which is a platform that provides us with the ability to create an Apache Cassandra instance. Their focus is generally providing Apache Cassandra services with other enhanced tools such as AI. Our focus will just be using the platform to be able to create to be able to create a database. There's no, this course is not sponsored by them. This is just a way of just being able to learn. So I thought maybe this would have been easier. So these are just the steps. So let's first of all sign up for DataStax. Click on that link. It should open a new tab. Then click on this first link, astra.datastax, this link that I'm highlighting. Click on that, which should take you to a page that looks like what you're seeing on your screen. Once you get here, an easier way is just to sign up with Google. I won't do that. I've already done that. So pause the video, do that. And once you're done, you should end up to this page. All right. I hope you've been able to get to this page. So sometimes you might realize I'm pausing intentionally just to allow you to just get to where I am. So once we get here, what we need to do is there are a few prompts, a few things. What we're interested in is most the databases part. Just click on databases. There's some quick link shortcut on that first page, a landing page. But you can always just click on databases. It should take you to this page. Sometimes the landing page might be modified at that particular time that you end up watching this particular stream, because this stream is a video that we posted on YouTube, and it's going to, so after this particular workshop, it will be posted on YouTube, and some people might have access to this stream maybe 1 year later, and platform might change, the platform itself. All right, so once you get here, we're just going to create a database. So we're going to create just a normal database. We don't want a whole lot of an enhanced AI database. You can just click on serverless, non-vector. Then we can write here whatever that name that you want to have the database. So we mentioned that when it comes to working with Apache Cassandra, we have database, key space, then table. So here we're going to have a name. You can give it any name. I can just give it learner or something, learner. And then key space, you need a key space. I can call this key space, you can create multiple key spaces, but for now I'll just call it example. Small example, and small, it should be small letters. And then provider, AWS. So behind the scenes, these are the providers that actually would provide you with that, so you can deploy on their platform. Yeah, so select a source, just scroll down, choose EU West, and then create database. It's free, by the way, but you can still connect. You can still use it for maybe long run. If you want to use it in the long run, maybe you could do that as well. So yeah, it's going to install the database, and then we can be able to connect to it. But as it installs, here it says pending. It will say successful afterwards. As it does that, we can just do a few other things. We need to set up a few other things. So here you can set what user you would want to interact, the type of user you'd want to interact with the database. We want to have a database administrator who can be able to update, delete key spaces, and do other things. So I am going to click on generate database token. And you can see here, this is what we have. So this is what we have. These are just credentials for that particular user. You can click on download token details. Just download it. You don't need to copy it. Just download it. It should download to your computer in the downloads location. That's the first key information that we need. The second one, we need to also get what are called secure connect bundles. These are just information that contain SSL as well as TLS files. These are for encrypting and decrypting the data that you would have if you're going to be, interacting with another platform. Like, we're going to use Google Colab, but in order to use Google Colab and work with data stacks, we need to, because there will be some communication in between, we need to be able to secure our data. So we can also do the same thing by getting this bundle, which should also download another one. So let's click on EU West, select region, and then download secure bundle. All right. So, and that's it. Generally, that's what you need to set up initially. So once you get there, you can now go back to overview. And here you can see we have key spaces. Let's create another key space. This other key space, we will call it, we will call it telecommunications. Let's call it telecommunications. Okay. So you should have two key spaces. Let me even just zoom in a bit. It's 100, 125. So you should have example in telecommunications there. Okay, once you've gotten there, by the way, pause the video and rewind if you feel like I'm too fast. Yeah, and already we have an instance. It's active, an Apache Cassandra instance that's active. What we need to do again, so once we get here, what we need to do is now go back to our notebook. We've already created a database, which we did. Ours is called Lana. Key spaces, we actually created two key spaces, and we've generated application token and also the bundle that we need. So let's connect to now that instance. What I'm going to ask you to do is to upload those two files that we have. So go to the far left of your notebook. So go to the far left over here. Then click on this link. So you should see upload session storage. Then choose the two files that you have. Just say, it gives you a warning, just say okay. It just means that if you close this session or the session, the tab, if you close the tab and it disappears the files, you'll have to re-upload the files, which is okay. Then upload the other JSON file as well. So you can see here we have Lana token JSON and secure connect Lana. So those are the two files that we need to upload. They should be here. If you find yourself going maybe inside configuration, just refresh the entire thing, the entire page. That should work. Now let's go to this tab, secure, setting up the connection. So we need to, you see this file over here that we set here, the secure connect bundle. It should be the same name as this name, so we can just name it as Lana. So that it's lana.zip, and then lana dash token. So here just change this to lana token JSON. And generally that's it. So you can run this and it should connect to our database. It gives us a few warnings, but it should say connected afterwards. And generally that's it. We've connected now to our, we're connected to our Cassandra database. And now we're going to learn how to do different things. But at this point, pause the video, just ensure that you've done what I've talked about here. You can also do it just below here. And then we can continue. I'll just be continuing after like 5 seconds, but you can pause the video, pause the stream. It just helps because there are people who are fast. Some of us are slow. If you're slow, you can always rewind a bit to just connect. Right, so let's learn how to load and read data once you have connected to Cassandra. So, and mentioned earlier that when we connect, by the way, I had not explained a few other things. So inside here, we decided to set the bundle to set up the bundle that we have. The same case we do so for the JSON file that contains the client ID and secret information. If you open JSON, you'll find that information. Then we use the plain text auth provider that we imported here to be able to get the credentials, and we set them up and we pass them to the cluster class that we also imported. And then in addition to just the cluster class, we the auth provider parameter in the cluster instance that we are setting up here, we also set up the secure bundle, and also we pass that to the cluster instance that we are creating here, and we connect to that cluster. And then we just once we connect, we actually have a session that we can be able to work with. So here we are already connected to our cluster, and we now have a session that we can be able to work with. So in order to interact with the data or to perform some operations against or on the Cassandra instance, we can use session.execute, then pass our CQL query, which more looks like the SQL query. It's just the same language. So we have not the same language, the different languages, only that they seem the same. So we use create table if not exist. So inside the key space, so example is the key space that we created. Then we want to create a table called users inside the key space that will have ID, name and age. It will have ID would be it would have the data type integer, name text data type, and age integers. Primary key will be just we will be setting so that our primary key, the ID column, will be the primary key in that situation. And then run that, and then we should have our data set. So we've already executed that, so we should have that table, and then we can insert data to that table. Insert into the keyspace.table name ID. We set also the definition of what we want to insert. So we want to insert the value for ID to be 1 John Doe, then which is the name, and age 30, the same case. So we execute that, and we also execute this other one. So we insert 2 records which we have, and then we can retrieve the data from, again, still the SQL table by just simply setting up our query, SQL query. So select star from example.users table, and that will be stored in rows. Then we can iterate over those rows and then close the session here. And you can see we've been able to retrieve our data from Cassandra. All right, pause the video and then work on this challenge that we have here. Just contains, remember that telecommunications key space that we created? Yes, that's the one that you're going to do. You're going to connect to our cluster. So here we've shut the session. We've closed it. So you need to rerun this. Well, technically, the code that you would rerun would be this one, so that you can be able to create a new session. Then once you have done that, then we can continue. Once you have done that, you connect to the cluster. You then create a collogs table like what we have done here. But now not for users, but for collogs inside the telecommunications. So don't forget telecommunications key space. Then, yeah, pause the video and then work on that challenge, and then we can continue. All right. So once we have stored data inside, let's say, users table in the example key space, then we can again update that we can update certain records, the values for certain records. So for example, let me connect to the cluster, and once I'm connected, I can then use this CQL query, update example users. If it's multiple lines, by the way, you'd have to use triple, and here you'd have triple quotes if it's multiple lines. So but that's not what we want. It's just one line. So update example users, then we set the age is what we have, 50, where ID is 1. So we pass the query to the execute function, and we set now our condition. So this where age is where age, no, not age, where ID is 1, we set the age to 50, and yeah, that's what we do. So age is 1, so age not 1. So for John Doe, that's the first record, we should have 50 as a result of this. So here we're also deleting the second. So this is updating, but we can also delete users. So we use the delete keyword, delete from example users where ID is 2. So here we will delete this one. So let's run this. If we run this, this is for deleting. We should be able to see that we only have now just one. We have one record, but the record has 50 as a result. All right, pause the video and then work on the challenge. Okay, so once we have gone through that, but by the way, make sure you have worked on the challenges, because they tend to build up towards what we are doing afterwards. So once you get there, so the next thing that we do is to load our, to learn how to load data, maybe CSV data into Cassandra. You might have some data that's stored periodically in a CSV file. But even one of the things that one of the reasons that we are doing this is because sometimes you might want to, in your data pipeline, store maybe some data you've pulled from Cassandra, maybe store that data in a CSV file. But again, that loading process is what we will get to learn. So assuming that we are not going to learn, maybe we'll get to learn about that, but this case we are going to learn how maybe it could be that we might want to store maybe some data back to Apache Cassandra, maybe some CSV data that we've stored somewhere in a CSV file. We might want to store it, but it's important to also get to learn about this step. So assuming that we have this data set that is stored here, it's an example. It contains actually the same, just more information about what we have here, similar information. We might want to store that data, this data inside now this particular users in the example key space in the users table. So we can load the data with pandas, which we have here, and then we can set up the query that we will use to insert data into that Cassandra instance. Then we use a for loop. So if you follow along, especially in our YouTube channel, we have a series on pandas, the libraries that helps you to practice more. Actually in a few of those challenges we've gone through, we talk about how to iterate through a pandas data frame, which is a tabular structure. So that's what we are doing here. Essentially, we are iterating through a pandas data frame using df.iteros and this for loops. So we're using a for loop to iterate through the df data frame, and we're storing the index of each record in the index variable and the row values in the row variable for each and every iteration. Then again, in each and every iteration, we run this code. So we execute this query, the same query for each and every record and the respective rows or records values, so ID and name. And we do that to insert the data into Cassandra. And let's run that. It should take a few seconds. So for that, it's done. And then we can now retrieve now the users, all the users that we have in that particular data set, in that particular database. So if I run this, I should be able to see all the records. So you can see all of them, which have been inserted, as you can see here. Okay, so that's a task. Pause the video and then work on the challenge. Okay, the last thing that we're going to learn, which is the most important thing, is how to create a data pipeline using Python and Cassandra. We'll be implementing those concepts that we've just learned in those sections. So how to load, read, update, delete, and also load data into Cassandra. We'll just actually be implementing those, but now using a structured approach that entails creating a data pipeline. So far, if you've been following along these data pipeline, data engineering workshops, which you can see on your YouTube page, there's a section you might see on just a playlist on data engineering with Python. You'll get to see that we can be able to work with, when we are creating a pipeline, we can use the approach where we have 3 different components. We have the extract component that basically pulls data from different data sources, and then transform data. So once we pull the data, we can transform that data in a different component that's called the transform component. And load data, which is the load component, just takes the transform data and loads it elsewhere. So we can decide to, when we use Python, we can use functions to be able to create that data pipeline. So we can have an extract function to pull data from different data sources. In our case, we'll just pull data from Cassandra. Then in the transform component, we'll use a transform function. So we'll get data, the extracted data, pass it now to the transform function. Then after that data has been transformed, we pass it now to this other function, which is the load function that we will create. In addition, we'll also create just a connect function to allow us to be able to connect to the instance or the Cassandra instance that we want. So for example, here we have divided now the different components. So starting off from here, extract data component, transform data component, and load data component. So these ones, extract data pulls data from Cassandra. Transform transforms the data using Python. Then we load it to a different, so we could decide a different instance or the same instance. Doesn't matter as long as it's serving the, it's helping us answer the research question initially. So, but initially we create a function here called connect Cassandra to just be able to handle the configuration information, like this information that we had here, in order to have it appear in a manageable way or a reliable way, in a way that we can be able to put into production. We can enclose this code, that code, into a function, and what we return is just the session itself. So this is our function that we're going to set up our information. But now you need to change something. You see where it says Cassandra? You need to change that into the names of your file. So here we talk about learner. So secure connect learner. The same case, learner token. So run that once you have done that. Okay. So the same case, once we have this, I think this code we are familiar with, so we should be okay. When it comes to querying data from Cassandra, we would need to set up the query that allows us to do that. Here we are creating in Python what is called an F string. An F string allows us to be able to define variables in that string. So in this string, which is CQR query, this is a CQR query. The only thing that what we have enclosed here in parentheses and also concatenated or brought to, not really concatenated generally, but it's still the same, or it's just variables. And these two variables will pass them through the extract data functions, the parentheses that we find here. So here we can define a key space, whatever key space that we want, and also the table name. This just make the code here a bit more modular or dynamic. That way we don't have to rewrite the key space every time that we want. So that's what we do here. We set up a query that will select data from a data source, that's a Cassandra database. Then we execute the query. Here, what we are doing simply is just that we are just iterating through now the queries that we've gotten, and we store that, after the iteration, we store that data inside our pandas data frame. So we will get the rows that we'll get here, we'll store them as a list of dictionaries. So each row we actually convert it into a dictionary. So we have a list of dictionaries in this place, and then we pass that data to the pandas pd.dataframe function that essentially transforms that data into a data frame, and then we can preview that, which will go in the output. Then we just print out the text data extracted successfully. That's just a basic way of just pulling data from Apache Cassandra, then loading it into pandas, and then we can work with that data with Python efficiently, using maybe some specific data manipulation tools that we might want. But yeah, once we pull that data, we return it. So this function will return that data, and it will later pass to the transform data function, which will do transformation technique. So yeah. By the way, aside from just pulling, we might have maybe another data source, maybe a CSV file or MySQL database. We can also do the same thing, but it adds into some sort of complexity. It adds up over time, especially when we have bigger use cases and we are trying to answer some complex research problems, or even just basic research problems. But how you answer that, you would need data that comes from different data sources. Again, it depends with how you approach it as a data analyst or data scientist. So let's run this. You can also run that. Once we gotten that data from extract function, we pass it to transform data df. Then we reference the df. We actually access the df data frame, the name column in the df data frame, and we apply the string, this lower function from the string module. And we apply it to that column. So essentially what we're doing here, we are transforming the these names into lowercase. The ones that you see here, Frank, Chloe, Nina, Jack, into lowercase. So that's why we use the str.lower function, and we just print out the string data transformed when that happens. And we pass now that data to our load data, which will take now the data which it has been given, which will come in the form, it's df, so it will be passed here. It will be taken out to now again the specified key space. So we will specify we want to store this data now into a different key space or an existing key space table that we want. So, but here we can just simply set inside the load data function, which is the component that loads the data. We would set up this particular query that will execute this query that we see here. What it does is essentially it checks for whether the key space name is the key space that we want to use actually exists. If it doesn't, it checks not key space. It actually checks for the table if it exists in that key space. Then if it does, then it will just ignore this. This will not be executed. If it doesn't exist, if the table doesn't exist in the key space, then it will create a table that looks like this. And then we set up the query to insert data, like what we got to learn here. This is where we set up the insert query. That's what we do here for ID, name, and age. And then we just perform now the population. So we populate now the data back to Cassandra, just as we did in this previous section here. And voila, we load the data successfully. So that's what we do. And we are passing the session to this particular function, key space name, as well as a table name. And that's it. Once we have set up those components to run them, we can simply at the bottom, the main section, we can decide to, because functions, well, when you're working with Python, especially when you're running this as a script, Python script, you need to have this part at the very bottom section, and inside it you define what you want to run. Like for example, we connect to Cassandra. This is the first function that runs, the one that is at the very top, and the session is what it returns a session, which is stored here. We pass the session to extract data. So the extract data function takes the session, the key space name, which is the example, and users. So you can see key space and users table over here. And then transform data function will take the df data frame that it was given. So it was given from to extract data, it takes the df and it also gives out the df. This is what you see here. It stores it df transformed, and we pass that to the load data. So load data takes the session. So session, which is passed, the key space name example, and could be users clean, or we could decide to just even have users let's just okay, we can do users clean as well, but it doesn't, you'll be able to, we'll need to change something here. So we run that to run now the entire pipeline. What we want is what's going to be, we want to see data pipeline executed successfully at the end, which it has. So to check for that data, initially we had we can select the data from the call logs, so not call logs, users table. Should have updated this. So if I run this, I should be able to see the data from the users table in the example key space, which this is the original data, but the new data that I have is in users clean. Users clean, you can change that, users clean, which we should be able to see as a new table. So it should take a few seconds. So you can see now we have now the clean table that you see here. And essentially that's it. If you have, you know, this code and the rest of the code, this code, this, and also the connection one, if you store it in a Python file, you then have a data pipeline that you can be able to rely on to help you get to resolve the research question as a data engineer that you might be having. The other steps that you might want to take in order to secure this particular data pipeline that Cassandra provides, the idea wasn't to go into those other complex features. The idea was to introduce you to a way of being able to use Cassandra for creation of data pipelines. We started off a bit on how to create a database on a Cassandra database, which you can create. You can decide to do that separately. And also got to learn how to connect to that database, how to insert or load data, read data, how to update, delete data, as well as how to also load it maybe from a CSV file maybe to some other file itself. We've also provided some challenges that you can be able to work along. So feel free to also explore those ones, so that by the end of it all you have another skill set that you can always rely on. So knowing how to work with Apache Cassandra can be something that you can say you already know how to work with Cassandra. And in any case, if you ever get an opportunity that allows you to explore that technology or those two technologies, then it can be a whole lot easier. At this particular point, pause the video and then work on the challenge. If you're an Afterwork member, again, you have the solution notebook that you could always refer to, but we highly encourage those who are not Afterwork members to also explore that. We normally have videos as well as courses posted on almost every other day. So if you're looking towards undertaking this journey seriously, you could always consider that. So yeah, so that's it with regards to this learning experience. If you finished the challenge, then that should be it. Next steps, I've already talked about maybe going back to explore how you can be able to secure your pipelines. But again, you could also look into what types of pipelines you can create using Apache Cassandra as well as Python, because what we've created here is not a complex one. We've gotten to learn how to import data from or to extract data from a Cassandra instance, and also to load. That's usually the basic things to learn, but you can also get to also explore how you can also interact maybe with Cassandra plus Python plus Redis or plus MySQL plus Postgres or other data sources. And also just working on projects, which might be helpful. All right, so that's it with regards to this learning experience. If you did find it informative, valuable, be sure to give it a thumbs up. That's what we ask in return, by the way. Just give it a thumbs up. It just tells us that we're doing something that is of value and it may help many people. It helps us just to know that, we should keep on doing what we're doing. And if you'd want to be informed when we post such future learning resources, be sure to subscribe to this channel. And all the best in your learning journey. If you have any questions, feel free to ask in the chat. All the best. Bye-bye.